Now let's take a look at current in a parallel circuit. And where we're going to start is with a quick review of current in a series circuit. So you recognize what we have here. There's only one path that the electricity can take, therefore it's a series circuit. We have a resistor, R1, 10 ohm resistor. We have a power source, which is a 50 volt battery. So let's go ahead and review the equation. As you know, the equation is E equals IR, where we have E being the voltage. Okay. Amperage is what we're going to be looking for, and we know the resistance is this R1 resistor at 10 ohms. So let's go ahead and play with the equation. If we're going to solve for I, then we're going to have to divide both sides by R. So I is going to be E divided by R. I'm going to neaten this up a little bit so so we can do most of our work in the middle of the drawing. Don't forget, at this point you want to probably do a quick sketch that looks like this one and do your math work on the sketch. It's a little bit easier when you're trying to figure out if something went wrong. So, rewritten, I equals ER, or the amperage, the current of the circuit, equals the voltage divided by the resistance. And we're going to figure that this is the plus side of the battery, this is the negative side, therefore the current flow is going to be in this direction. So let's go ahead and solve for current. If we put E on top, that is 50, and resistance on the bottom, that is 10. 50 divided by 10 equals 5, which tells us that the current equals 5 amps. We use a little a to show that. Okay, next we're going to take a look at a parallel circuit. And we're going to do the same math, but we're going to do it in pieces of the circuit. Okay, here's our new parallel circuit with two resistors, R1 and R2, both of them 10 ohms. And we have the current already noted, and we'll do some solving here. So why don't you go ahead and pause here and draw out this circuit diagram, and then you can work on it. I'm going to go ahead and label the plus side of the battery, the minus side of the battery, and the total amperage of the circuit coming into the battery and going out of the battery. I'm going to label total, T. Okay, so there we have those. And I'm going to put down that the amperage at R1, I'm going to call that I1, and I'm going to call the amperage at R2 I2. Now, unfortunately, this doesn't print as nicely as it could. That really should look like an I, as opposed to a 1. That can be a little bit confusing, so I'll change that. Okay. So the first thing we ought to notice is that the total amperage of the circuit, both coming and going from the battery, is 10 amps. And yet the amperage at the resistor number 1 and resistor number 2 are 5 amps. Well, that kind of tells you something's going on, where if we have 10 amps leaving the battery, which I'll put down here, 10 amps leaving the battery, and going up to resistor 1, at that point we have 5 amps. And we can say that that then returns to the battery. Okay, but when it gets back to the battery, it's 10 amps. Okay, where did that extra 5 amps go? It went to the other resistor. So if we take that same 10 amps, it leaves the battery, it goes to this resistor, R2, and at that point the current is 5 amps. It leaves that resistor, returns to the battery, and it's 10 amps when it gets back to the battery. We can pretty well say that in a parallel circuit, the amperage of the entire circuit, which is 10 amps, is equal to the amperage at each of the resistors when they are added together. So the 10 amps total is equal to 5 amps plus 5 amps. So we can come up with kind of a rule looking at this. And that rule, I'll write up here, it is the total current for the circuit is equal to the current at different spots in the circuit. So here we have I1 plus I2, and it just keeps going. So we can say that the total number of points where we measure the current at resistors throughout the circuit, we add them up, and that gives us the total amperage of the circuit. So our final takeaway is that the total amperage of the circuit is equal to the amperage at each of the points where we measure it across a resistor. And in this case, take a look at the fact that both of these resistors are the same value, 10 ohms. The next example we're going to look at, the resistors are going to have different values, and let's see what happens to the amperage there. Thanks for watching.